Welcome to School of DAPPS. On this channel, we turn aspiring developers into skilled blockchain experts across various network and technologies. In today's video, we'll be exploring something every Solidity developer needs to understand, and that is Constructor. By the end of this lesson, you will know what constructors are, how they work, and how to use them when building powerful smart contracts. So let's get into it. A constructor is a special function that runs once, right when you deploy your smart contract. Think of it like a setup function. When you launch a new contract, the constructor sets up some starting values like the owner, a token name, or any config data. It's optional but very useful when you want to initialize things only once. We start by writing the license we are using. SPDL license identifier MIT. It's just a way of saying this code is open source under the MIT license. Then right below it, we declare the version of Solidity we want to use. Pragma Solidity caret 0.0.8.26. The caret means we want any compiler version from 0.8.26 upward. Now let's define a simple contract with a contract keyword and call it X, and then a curly bracket. Inside of it, we are declaring a public string variable named admin by writing string public admin. The public keyword means anyone can access this variable from outside the contract. Then we add a constructor using the constructor keyword, and then parentheses. We would pass in a parameter of type string memory underscore name. The memory keyword here tells Solidity that the underscore string is a temporary value stored during function execution. Let's assign the value passed to the admin within the constructor block, setting the admin variable to whatsoever value that is passed in. We will declare another contract which will be very similar to X. We will start with the contract keyword and name it Y, then a curly bracket, and declare a string variable called text. Then we will declare a constructor inside the Y contract also and pass in a parameter which does exactly the same thing like what we have in contract X. Then store the provided value into the X variable during deployment. Now let's talk about inheritance. In Solidity, one contract inherits from another, which basically means it can use the variable and function from that contract. In contract B, we are inheriting contract X and Y. What's happening here is that B is inheriting from both X and Y, and we are directly calling their constructor by passing in string as argument. Input to X goes to the X contract, and input to Y goes to the Y contract. The is X, Y is the inheritance list, while we will call the parentheses of input to X and input to Y the constructor argument list. This means when B is deployed, it automatically runs both constructor with those values. All right, now let's look at contract C. We declare contract C is X, Y, which means it is also inheriting from X and Y. But this time, we are not passing any constructor argument right away. Instead, we'll define contract C constructor inside the contract, followed by the X and Y constructor argument, then the curly bracket. What this does is that it lets us pass in value when we deploy C contract. Those values are then forwarded to the base or the parent contract, which is X and Y. So if we want to reuse the contract with different name and text, we totally can. So this time, instead of hard coding the inputs like we did in contract B, we are allowing the deployer to decide the value. Name gets passed to X and the text gets passed to Y. Now, before we move on, let's take a moment to talk about something really important: order of inheritance. So, you might be wondering, what happens if I list the parent constructors in a different order inside the child contract constructor? Well, here's the thing: Solidity doesn't care about the order you called them in the constructor. What actually matters is how you listed the parent contract after the is keyword when defining the contract. This rule is called the order of inheritance, and it simply means Solidity will always call the parent constructor from left to right based on how they are listed in the contract definition, not how you arrange them in the constructor body. So even if you swap the order inside the constructor, Solidity will still follow the inheritance order when deciding which construction runs first. This is super important to remember when working with multiple inheritance. Now, let's move on to a new contract. We will call the contract B. Just like before, it inherits from X and Y. But here, we define the constructor inside the child contract and pass in the argument directly. This works fine. When we deploy D, it will call both base or parent constructor with the value we are hard coded. We are passing the string X was called to X contract and Y was called to Y contract. And because X is inherited first, then Y, Solidity will call the X constructor first, then Y, and finally the D constructor itself. That's the order it always follows, left to right in the inheritance list. Now let me show you something tricky with contract E. Contract E is X, Y. In this child constructor, I will reverse the order of how the parents constructor are listed. At first glance, you might think that Y will be called first, but that's not how Solidity works. Even though Y is listed first in this line, Solidity will look at the inheritance order, which is Y then X, and stick to that. So again, X get called before Y. So if you are ever working with multiple inheritance, just remember constructor calls follows the inheritance list, not the constructor argument list. The key takeaway here is that Solidity does let you inherit from multiple contracts, and you can pass value to their constructor either directly or dynamically. But always remember, constructor execution follows the order of inheritance, not the order inside the constructor body. That's it for today's video. If you found this helpful, make sure you drop a like, leave a comment, and don't forget to subscribe for more smart contract tips from School of DAPPS. See you in the next one. Until then, keep learning and keep building.